Hey, it's Nancy. So in my first chain rule video, I mentioned some problems at the end and then just didn't explain them, left you hanging. Very rude, but a lot of you have asked me to explain those, so I am going to show you how to use the chain rule to find the derivative if you're given an exponential form like this, a natural log, square root, and also a bunch of you have asked me how to use the chain rule with the product rule, like to use the chain rule first or the product rule first. Can be confusing. Don't worry, I'm going to show you how. Okay, so say you need to find the derivative of something like this. We have an outside function, the exponential e raised to a power. We have an inside function, 3x, something that's more complicated than just x. So we'll need the chain rule. And if you don't know what I'm talking about, you're going to want to check out my actual intro chain rule video, my first chain rule video. Yep, that one. And this will all make a lot more sense. But for the chain rule, here's a reminder. First, we take the derivative of just the outside function. So here, the outside function is the exponential function, e raised to a power. The derivative of the exponential function is just the exponential function. So for the derivative of e, we write e. And when we take the derivative of the outside part, remember we leave the inside alone, leave the inside part the same. Just leave it alone, like so. We're not done. Remember, we also have to multiply by the derivative of the inside function, the derivative of what's inside the larger outer function. So the derivative of our 3x inside is just 3. And now you're actually done. Cleaned it up a little, it's proper form to bring that coefficient 3 out in front. But that's it. That's your answer for the derivative. dy dx is equal to 3e to the 3x. If this went too fast for you in any way, if you still have lingering questions about this method, doubts, for those of you who are British, please help yourself by checking out my chain rule how when video, my intro video. So another kind that I mentioned, a natural log example. 5x is what's inside our natural log, and the outside function is the ln. So we have ln of something, and that something is more than just x, more complicated than just x, so we use the chain rule. Same steps as before. First, take the derivative of the outside function, of the ln. To take the derivative of ln of something, we write 1 over that something. 1 over the inside of the ln. You might be thinking about ln x and how you know its derivative is 1 over x. But here, ln 5x, because of the chain rule, we write not 1 over x, but 1 over the whole inside you actually see here, 5x, 1 over 5x. We're not done. Remember, we also have to multiply by the derivative of the inside function, the derivative of the 5x inside. Derivative of that is 5. So the 5 and the 1/5 cancel, and it simplifies to 1 over x. Wait, what? Plot twist. It turned out to be 1 over x anyways. Yeah, that's awkward. It turns out that natural log of a number times x will still have a derivative of just 1 over x, like ln x does. It's a fun party trick. But the point is that you used the chain rule and you figured that out yourself because you're learning the chain rule. And this could have turned out differently if you had more x terms inside your natural log or powers of x. This wouldn't have simplified to be just 1 over x. So I just wanted you to be able to handle whatever ln function you're given. To find the derivative, it's going to be 1 over the inside times the derivative of that inside function. Okay, so let's do this one. Find the derivative, also known as y prime. I gave you Lagrange notation this time instead of the dy dx Leibniz notation, for those of you who feel strongly about your notation. Personally, I really prefer this y prime Lagrange notation, whatever floats your boat. So for this one, we have x squared plus 1 under a root, a square root. That square root is our outside outer function. And whenever you have a root of any kind, before you take the derivative, it's going to be easier to rewrite it in the form of a fraction power. 1/2 power, so we can use the power rule, but our outside function is a power to the 1/2. Our inside function is x squared plus 1, something more than just x, so we need the chain rule. To take the derivative of the outer 1/2 power, we'll use the power rule and bring down the 1/2 power to the front. Like that, and leave the inside function the same here. Leave the inside alone. We brought the power 1/2 down to the front. What's the new power going to be? By the power rule, we reduce the old power by 1, so 1/2 minus 1 is negative 1/2. Okay, and don't forget, not done, have to multiply by the inside derivative. We just focus on our inside x expression. The derivative of x squared plus 1 is 2x plus nothing, just 2x. And you're done. So the 1/2 canceled with the 2. It's considered nicer, proper to put it back into a root form in your final answer. A lot of people won't like you leaving a negative power in your final answer. This negative 1/2 power means 1 over the 1/2 power, or 1 over square root. That's why we've written here in the final answer 1 over root, the over root form. Why do we bother even putting it into a power form if we were going to put it right back into a root form? Because we're masochists? No. It was just easier to use the power rule on the power form. Okay, so a bunch of you have asked me, what do you do if you have the chain rule combined with the product rule? Do you use the chain rule first or not? Good question. Not obvious. By the way, if you don't know the product rule, you can check out my derivatives how video to see that. But let's look at our equation here. If you had only this half, 2x minus 5 to the 4th power, and not this, you could definitely use the chain rule on that to find the derivative. We have this outer function, power 4, inside function that's 2x minus 5. I know I sound like a broken record, but our inside is more than just x, more complex than just x. So we could use the chain rule on that. It would be a lot like number 1 in my first chain rule video, the very first one I showed you in the main video. But we don't have just that. It's also multiplied by this x cubed. So in the larger function, the big picture view, the biggest view, what we have is two things multiplied together, a product of two things. So that's your answer. You're going to use the product rule here first because in the largest view, we have a product of two things first and foremost. So just to remind you, the gist of the product rule is that when you have two functions multiplied together, the derivative will be the first function as is times the derivative of the second, plus the second function as it is times the derivative of the first. So let's try that for our equation. So we write the first factor as is, x cubed, times the derivative of the second factor. Now this is the moment where we use the chain rule within the product rule, because what we're about to take the derivative of is an outside function with an inside more than just x. So derivative of the outer function, the power of 4, by the power rule we bring down that power to the front and reduce the old power by 1, multiplied by the derivative of the inside function, derivative of 2x minus 5 is just 2. For a fuller, slower explanation of using the chain rule on a power like this, see that example number 1 in my first video. We're only halfway done. We're going to add the second function times the derivative of the first. plus the second function times the derivative of the first. Second function times the derivative of x cubed is just 3x squared, and that's it. That's the derivative. We can clean it up, simplify if we want to, or if we have to. You can clean up the coefficients in each of the terms, and then it's considered nicer and proper to pull out common factors to the front. So there's an x squared that appears in both of these terms, and there's a 2x minus 5 to the third power that's contained in both of these terms. We can pull those out to the front. I know it feels like grunt work sometimes to simplify this way, but we get this pretty little result in the end with 3 factors just multiplied together. So it cleans up nicely. So this is how you do the chain rule with the product rule. Chain rule inside the product rule. Will it always be product rule first? I'm going to be honest, that is usually what you'll see, but chain rule first with the product rule can also happen. Like, what if our product were inside a natural log? Then you'd use the chain rule first on the natural log, and when you go to take the inside derivative, since the inside's a product, you'd use the product rule then, and not first. It's less common to see, but basically, the first thing you'll do is whatever you need to do to handle the outermost form. So I hope that helped you understand more ways you'll need the chain rule. I know calculus is everyone's favorite. You don't have to like math, but you can like my video. So if you did, please click like or subscribe.